So in today's session, we are going to shift into the advanced topic of the artificial intelligence, which is the computer vision. As part of this computer vision, we'll cover topics like the what and why of computer vision, the applications of computer vision, and also we'll take a look at the difference between image classification, localization, image segmentation, object detection. Lastly, we'll take a deep dive into convolutional neural network, and also we will implement the same using Python. So what is computer vision? The central idea behind computer vision is to enable the systems or the machines to view and understand the world like how we humans do, okay? And to use that understanding for a variety of activities like image and video recognition. So this is a typical definition. The computer is a field of artificial intelligence that trains computers to interpret, understand the visual world. As part of neural network, I explained, what is the idea behind coming up with developing or they are developing or conceiving. What is the idea of conceiving with developing a neural network model, right? So the scientists in the past, they thought they want to give the brain to the system so that the system can think on its own and act accordingly without any manual intervention. Having a brain alone not sufficient. In addition to that, vision is also required. The classic example is the self-driving car. The very first step in self-driving car is computer vision. Okay, so it's what allows the cameras to see the world and make a car autonomous. Okay, the cars are bombarded with a lot of sensors and cameras. With the help of the sensors and cameras, right, the car can learn the external world, and then those the video information, whatever it captures, it feds to the algorithm, and then in real time it classifies whether, for example, in the case of traffic light, whether the car has to stop as soon as it sees the red light, or so these kind of classification and all done automatically, okay, with the help of the computer vision. The idea is it should have the vision. Okay, so without eyes, how we can walk, right? So having a brain alone not sufficient. You need to have the vision. Without vision, it's very difficult. Okay, so that is the whole idea of this one. So in addition to the brain, the scientists, they thought they want to give a eye or the vision to the system, so that with the combination of brain and eye vision, the system can solve many real world problems. Okay. There is another definition. So, right, so there are a lot of definitions are floating around in the net, regarding computer vision. Not only computer vision, even for the entire artificial intelligence, right? A lot of definitions, but these are the definitions, which are more apt to this topic. Okay, the computer is a subfield of deep learning and artificial intelligence, where humans teach computers to see and interpret the world around them. So here also, the human has to teach the computers with the help of the images. Okay, we need to, if we want to do some kind of image classification, we can do image classification using the convolutional neural network. That is the algorithm which in the case of self-driving car, it uses the CNN algorithm to do the classification, everything. Okay. Now, before we proceed with the convolutional neural network and all, first of all, let us understand what is the difference between human vision systems and the computer vision systems. In the case of human vision systems, let's say you have a plate full of fruits, different fruits are there. The human brain is much more powerful, and even eyes, right? The eyes and brain are much more powerful. Just as a human, when we look at this plate, we can distinguish which fruit is what. So this is grapes, and this is apple, this is bananas, and this is a grape, and this is a plate. We can say in a matter of a second. But when it comes to system, it needs additional devices, like the sensing device, camera, right? You need to have the camera, CCTV. So it has to capture this information, the real world, and then it has to fit into your system. Then system will in the system, in the sense, the algorithm. So algorithm will based on the images fed to this algorithm. For example, convolutional neural network, it classifies whether the fruit is apple, banana, or grapes, or is that a plate or something like that. The computer vision is used across industries, across different use cases. For example, in the case of self-driving cars, that's what I said, right? Self-driving cars enables, right? The computer vision enables the autonomous vehicles, the self-driving cars, to gain a sense of their surrounding by creating 3D maps out of the real-time images. So in this case, the cars are bombarded with cameras. These cameras capture video from different angles around the car, and it feeds this to your computer vision software. And then it processes it to identify whether it's a road, or it can, classify the traffic signs also, okay? Or it can understand the classify traffic signs. And supposing somewhere the curve is there, right? And the road, on the alongside the road, you can see the signboard, right? Curve is there, slow down, hump is there. So what we do is, based on which the car will decide, okay, whether it has to slow down or whether it's speed up. When it sees something like any hump, right? So it slows down automatically without any human intervention. And also in case of any objects that crosses the road or any the pedestrians, it can discover, right, what kind of objects are crossing the road or something like that. And then the car can steer its approach on streets and highways to avoid obstacles or passengers. And then it take the passengers to the destination. That is the whole idea of the autonomous cars, self-driving cars, right? So, and even nowadays, the pilot, right? The flights, aeroplanes, right? Or now they came up with something like autonomous thing, right? Pilotless thing. Okay, so the lot of tractions are happening around computer vision. And the next application is the facial recognition. In the case of facial recognition, right, so it plays an important role, the computer vision. So the computer vision, right, it finds patterns in elements in the data. The classic example is in our mobile phone. We can lock our mobile phone, right? We have some applications with that. We can lock our screen, and when you key in the password or the secret word, it can unlock your phone. The other alternative is the facial recognition. If you show your face, automatically it unlocks it. It's all possible because of the computer vision. And even in the healthcare and optical characterization, this and all we'll discuss it later. So at this moment, you just understand these two applications. Apart from the case of a retail store and all, right? So what we do is we use the image classification and other computer vision related algorithms in order to find out which all fruits are ripened, right? So which are fruits are ripened, those kind of things. We use this thing, the computer vision. So by knowing it well ahead, which fruits are going to ripe in the shortly, right, in the near term, right? So what we do is we alert the people to shift those fruits to some other place, so that if the fruits gets damaged, right, it should not spoil other fruits. Okay, so what is this is how the computer vision evolved. Okay, by 2000, by the 2000s, the focus of the computer vision has been shifted to much more complex topics like image classification, image segmentation, and object detection, and so on. Now we'll take a look at what is the difference between image classification, image segmentation, object detection. What is image classification? Let's say if I show you this image, and if I ask you what this image has in it, you will say it's a dog, right? So you can easily classify this object. It belongs to the dog class, right? In a nutshell, this is what the image classification is all about. Okay, we can train a multi-label classifier. Okay, and so for example, right, if I have something like, in this case, I have only one object is there in this image, only one dog is there. Supposing if I have more than one animals are there or more than one objects are there in my image, what can I do? So we can train a multi-label classifier in that instance, but there are some caveat with the multi-label instance. We don't know the location of the animal or object in the image, right? Unless you know where this animal is there, right? You cannot do the classification. So that is where the object detection is comes into picture. Multi objects, if you have multiple objects present in your image, you have something called object detection. What it does is it not only detects the location of the objects that are there in this image, and also it draws the bounding box around those objects. Okay, and knowing the object's location and drawing a bounding box is not sufficient. You should be knowing what these objects are, right? So before detecting the objects and even before classifying the image, we need to understand what the image consists of. That is where the image segmentation is very much helpful. Now you understood the difference between image classification and object detection and image segmentation. Image segmentation helps us to go one step further to understand what each object is all about. So is this a dog or is it a cat? Is this a dog or cat or anything else or human face? Okay, so with that, we should be able to understand. And okay, and we have something called image localization. As I said, the object detection, if you have multiple objects, in this case, if I ask you what is there in this image, Mala, you joined just now, good that. Mala, why don't you tell me what is there in this image? Can you type it in the chat window quickly? What is there in this image? Or anybody else? Sumita, you are there. Sushmita, you are there. Okay, what is there in this image? Karthik might know the clue. I have explained it. And Mala, tell me what is there in the image? An animal is there. What animal is that? A dog or cat? It's a dog, right? So the moment when I asked Mala, she said, in this image, a dog is there. Do you guys think only dog is there in the image? The surrounding of the dog, you can see the grass is there, right? In the background, something else is there. But human brain, right? It looks at the object that are very specific to us, that are interest to us, right? This is called object image localization. So in the case of, so in this case, we have only one object is present or only one animal is present in this image. So hence it can do the classification, whether it's a dog or a cat. If you feed Azure 1,000 images like this, each image you have only one animal in it. So it can classify, okay, whether it's a dog or cat or human, it can tell. If I have more than one object or animal or more than one object is there, that is where the object detection comes into picture. The object detection, what it does is, right, it does something called image localization. It first of all, it should know in which location the animal is there. It can be here or it can be here, it can be somewhere else. The animal can be, located, anywhere in this image, right? It can be sitting here, it can be sitting here, it can be sitting here. But that's what I was explaining here. I was talking about the multi-label classification. So if I have more than one object is there in an image, we can go for multi-label classification. Do you remember at the beginning of the data science training program, I explained you, I gave you the overview about the machine learning model, right? Before we started the machine learning algorithms, I explained you the types of classification problems. One is the binary classification problem, multi-class classification, multi-label classification problem. Since you have multiple objects present here, you can use multi-label classifier. But the issue with that is, right, first of all, it doesn't know which location the objects or the animals are there in the image. So first, the object detection. So that's where the object detection is coming into picture. We cannot use multi-label. in this case, in the case of image processing. So in this case, object detection, what it does is it does the image localization. It finds out where the objects are there in this image, and also it draws the bounding box for each object in this image. So this is what called your object detection. Okay, identifying the location of the objects or animals within the image, within this image, and then drawing the bounding box is not sufficient. Also, we should be knowing it. What object are they? What animals are they? Right? Before detecting the objects and even before classifying the image, we need to understand what this image consists of in it. This is where the image segmentation is very much helpful. With the help of the image segmentation, we can find out, right? So what we do is we can divide or partition the image into various parts. We call that as a segment. It is not the great idea to process the entire image at the same time, okay? Because there are multiple regions are there in image which do not contain any information. For example, if you look here, right, in this region, we don't have the information what we look for it. Okay, so that is right. So by dividing the image into segments, we can make use of the important segments that needs to be processed in the image. So this is in a nutshell, right, how the image segmentation works. It simply segments the image, and then it looks for the segment where it has the information that are of interest to us. Okay, so in this case, it goes and checks, okay, this is a dog, this is a cat. With the help of image segmentation, we can go one step further and find out what each object is all about within this image. So now you understood the difference between these three: image classification and the object detection and image segmentation. The image classification helps us to classify what is there in the image, and whether a dog or cat or human. The image localization, that helps us to identify the location of the single object in the image, whereas the object detection specifies the location of the multiple objects in the image. Lastly, we discussed about the image segmentation. The image segmentation creates a pixel-wise mask of each object in the image, which means it creates a segmentation, image segmentation. And then with the help of image segmentation, it can identify the shapes of different objects. This is very important. The image segment identify the shapes of the different. By identifying the different shapes, it can tell whether it's a dog or cat. In this case, along with the dog or cat was sitting next to it, right? It identifies the shape, which one? The image segmentation. Okay, the next thing is, the next thing is, when I asked you what is there in this image, you said, it's a dog. If I ask you what is there in the image, you can tell this is a bike. What is the big deal here, right? So human brain is much more powerful, and we are gifted with powerful eyes. With the eyes, we are able to process quickly, hey, this is a bike, and this is a two-wheeler, and this is a dog. But how do computer interpret the images? How does this computer interpret? Any idea, anyone? If I see in my laptop, I have a lot of images are there. So how will my computer interpret which images, what object in it? So how is it possible? As a human, just by looking at the image, we can say, hey, this is a human, this is a dog, this is a cat. We can tell quickly. But how does the computer interpret the images? Every image can be represented as a matrix of or array of pixel values. Array of pixel values. Okay. So when it comes to the computer or the system, the algorithm, it can recognize an image in terms of zeros and ones. Pixels, array of pixels. An image is nothing but an array of pixels. Okay, the pixel, what is a pixel? Pixel, so look here, so according to us, this is a bike. And how the system can understand, so for this bike, it has some pixel values here. Okay, each image has a pixel value, the width and height of this image. For that, it will have some pixel values. Okay, so the computer can see an image as zeros and ones. Okay, and an image is an array of pixels, I said. And this, look here, this image is according to that computer or the algorithm, it's a the array of pixels or matrix of pixels. What is the pixel? This is, each and everything, right? The cell is called your pixel. This pixel is the smallest unit in an image. Okay, when we take a digital image, it is stored as a combination of pixels. Let's say in mobile, you take the photo, right? It is stored as a combination of pixel. Each pixel contains a different number of channels. Look here, I have used different number of channels. If it is a grayscale image, it has only one pixel. Whereas if it is a colored image, it contains channels called red, green, blue. Okay, the red channel will have 0 to 25. The pixel values ranges between 0 to 255, 0 to 255, 0 to 255. Okay, the computer stores images in a variety of formats, right? So the most commonly used the pixel type, right, is the BGR, blue, green, red, and this is the one. Each pixel, so in this case, right, in the case of color one, each pixel is combination of the brightness of blue, green, and red, ranging from 0 to 255. Okay, and the red color is 255. Okay, and in the case of green, it is 255, and blue is 0. Okay, blue is 0. Okay, each value between 0 to 255 range of values, right? 0, 1, 2, 3. Each value has different colors in it. In the case of grayscale, 0 is black and 1 is white. Sorry, in the case of grayscale, 0 is black and 255 is white. Even the case of grayscale image, in the sense non-color image, okay? In the case of grayscale image, it has only one pixel in it. In the case of the colored paper, in the case of colored one, right, it contains 3 channels: red, green, and blue. Look here, this is how it will be like this. The channels are like this: red, green, blue. Okay, each pixel, right? So it contains 3 channels. Okay, in the case of grayscale, it has only one channel, and yeah, it has only one channel, and the values are ranging between 0 to 255. Whereas in the case of color, it has 3 channels. Each pixel has 3 channels. In the case of grayscale, it will have only one channel. Okay. This is a fundamental thing. You should be knowing it. Okay. And each channel of each pixel, we can say this way also, each channel of each pixel has a value between 0 to 255. Each of these values are represented in binary. Okay, in binary, before a computer can understand the image. That is what you need to understand this one. The next one is, yeah, that is what I mentioned. Color channels are referred to as the number of colors in an image. The grayscale images are represented using a single color channel of black and its variations. And each pixel will get a value between 0 to 2. It is an 8-bit representation. This is what you need to remember it. And the red GB, already we discussed it. Okay, next, what we will do is we will start understanding or exploring what is convolutional neural network. So we discussed about the difference between image classification, object detection, and image segmentation. And now what we will do is, and also we explored what an image is all about. It is nothing but an array of pixels. Each pixel value ranges between 0 to 55. In the case of color, each pixel will have 3 channels: red, green, blue. And in the case of grayscale, it will have only one channel for each pixel. Remember this. So now what we do is, using convolutional neural network, how we can do the image classification.